Episode 2, How AI Works, Algorithms and Data. Hey everyone. Welcome back to AI Awaken. Today, we're diving into something super important, how AI actually works. Now, I know what you might be thinking, why bother learning about data and algorithms? Well, understanding these two things is like unlocking the secret behind how AI thinks and makes decisions. Imagine this, your favorite apps recommending the perfect song or your voice assistant understanding your commands. It's not magic, it's data and algorithms working together. Once you get how these two pillars function, you'll see AI differently, not just as a fancy buzzword, but as a technology that's transforming the world around us. By the end of this episode, you'll have a clear picture of why data and algorithms are at the heart of AI. Interesting fact, here's a fascinating thought, AI, in a way, was always there, waiting to be discovered. Just like electricity existed before humans knew how to use it, the potential for AI has always been part of the universe. It's only recently that we've developed the tools and knowledge to harness it. Pretty cool, right? Part 1, the role of data in AI. Let's start with data, the essential fuel that powers AI. To understand how it works, think about how a child learns to recognize a dog. You'd show the child many pictures of different dogs, some big, some small, some fluffy, some sleek. Over time, the child starts recognizing the common features and patterns that define a dog. Similarly, AI learns by being exposed to vast amounts of data, processing it, and finding patterns. Data is essentially information, anything that a computer can process. It can be numbers, images, text, audio, or any structured or unstructured information. In the context of AI, data serves as the foundation on which learning algorithms build their knowledge. The more data an AI system consumes, the better it becomes at identifying patterns, making decisions, or predicting outcomes. Think about your favorite music app. It doesn't just randomly recommend songs, it learns from your listening habits. It tracks what songs you play, how often you replay them, when you skip tracks, and even what genres you explore. By analyzing this data, it builds a profile of your musical preferences, allowing it to suggest songs that match your taste. A great real-world example is Netflix. It doesn't just track what you watch but also when you pause, rewind, or skip a show. This rich dataset allows the platform to understand not just what you like but how you watch. It uses this information to recommend shows you're more likely to enjoy. Without this data, AI systems like Netflix's recommendation engine would be guessing blindly. In essence, data is the foundation of AI's ability to learn and adapt. The more diverse and plentiful the data, the more accurate and reliable the AI becomes. Example, Netflix gathers data on what you watch, when you pause, and even what you skip. It analyzes this information to suggest shows you might enjoy. Without this data, AI wouldn't know what to recommend. Part 2, Understanding Algorithms. So, how does AI actually make sense of data? That's where algorithms come in. An algorithm is like a recipe, a set of instructions that a computer follows to perform a task. In AI, algorithms help process data and find patterns. But wait, isn't that just computer programming? Not exactly. While computer programs are a set of specific instructions written by humans to perform tasks, algorithms are more about the logic or steps needed to achieve a result. Think of it this way: a computer program tells the machine exactly what to do step by step, while an algorithm defines the method or strategy to solve a problem. In AI, algorithms learn from data to improve their problem-solving methods rather than just following fixed instructions. Algorithms are the backbone of AI, and they come in many forms, each designed to solve specific problems. One fundamental and intuitive type is the decision tree algorithm. Imagine you're trying to identify an animal by asking a series of yes or no questions. Does it have fur? Can it fly? Is it a carnivore? Each answer branches out to another question, gradually narrowing down the possibilities until you reach the correct answer, like a flowchart of decisions. In AI, decision trees work similarly, but on a much larger and more intricate scale. Instead of just a handful of questions, they analyze vast amounts of data, breaking down complex problems into a sequence of smaller, manageable choices. Each decision point, or node, represents a feature, while the branches represent possible outcomes. This process continues until the algorithm classifies the data accurately. While decision trees might seem simple, they become remarkably powerful when combined with other methods or structured into forests, collections of trees working together to boost accuracy and reliability. Example: in spam detection, an algorithm checks incoming emails and follows a set of rules. Does it have suspicious words? Is there an unknown link? Each yes or no moves it closer to labeling the email as spam or safe. Part 3: Techniques to train AI systems. Now that we know what data and algorithms are, let's see how AI learns. There are three main techniques: supervised, unsupervised, and reinforcement learning. Supervised learning: imagine teaching a dog tricks with treats. You show a labeled example, like telling the dog to sit, then giving a reward when it follows. In AI, supervised learning means feeding the algorithm labeled data, so it learns the correct output. For example, identifying spam emails by training on labeled spam and non-spam examples. So in supervised learning, the machine is trained on labeled data, which means the data is already equipped with answers. Unsupervised learning: this is a way in which a machine learns the hidden pattern in the data without being provided with any labeled data, means let the machine learn itself and don't provide any answer to it. This is like giving a bunch of photos to someone and asking them to group them without giving any hints. The algorithm looks for patterns without labeled data. An example is clustering similar customer profiles based on shopping habits. Reinforcement learning: in this, the machine learns through trial and error, so any time a machine takes a right decision, it rewarded by giving positive feedback, and if the machine takes wrong decision, it is penalized by giving negative feedback. Think of a game where you score points for good moves. The AI tries different actions and learns from successes and mistakes. Self-driving cars use this technique to improve driving skills by constantly adapting to road situations. Now let's talk about some common myths or questions pop up in our minds. Myth: AI can think and feel just like humans. Fact: despite its impressive capabilities, AI doesn't actually think or understand. It processes data purely based on predefined algorithms, without emotions or consciousness. Question: why do AI systems sometimes fail? Answer: AI failures often result from a lack of high-quality data or algorithms that aren't properly designed. Just like humans can make mistakes when they lack information or use flawed reasoning, AI can produce inaccurate results when its data is incomplete or its algorithms are flawed. Conclusion: so, To sum it up, AI works by using data as its foundation and algorithms as its brain. These algorithms process data to recognize patterns, make decisions, or predict outcomes. The more data we provide, the smarter and more accurate the AI becomes. Think about it, from your favorite streaming service suggesting the next movie to your phone's keyboard predicting your next word, AI is seamlessly integrated into our daily lives. It's not magic, it's the power of data and algorithms working together to make smart predictions. As we move forward in this series, we'll dive deeper into how AI continues to evolve, influencing industries and shaping the future. So, whether you're curious about self-driving cars, AI-generated art, or intelligent personal assistants, stay tuned, we've got it covered. If you found this episode insightful, make sure to like, share, and subscribe. Your support helps us bring more content on how AI shapes our world. See you in the next episode.